representations in tables, in graphs, and as equations. Okay, so ladies and gentlemen, what I'm going to do right now is I'm going to give everybody a half sheet of paper that looks like this. But in the meantime, if you could all look at the board, because you don't have your half sheet of paper in front of you, on the board it says, the distance Lisa runs from her house to her friend's house can be written like this equation. Okay, so that's one representation. We're going to represent this equation as a table, and then we're also going to represent it as a graph. All right, right now, when you and your group members get the half sheet of paper, I want you to look at this table, and I want you to convert it into a graph, and then stop. Okay, so my graph is half filled in. I've got some zeros, and I have the number 5 here. Okay, so I'm going to keep reading the equation. It says, the equation is d plus 4 equals 2t, where d represents the distance in kilometers from her friend's house, and t represents the time from her house. Okay, this 0, does this 0 represent d, or does this 0 represent t? What do you think? Kyla? T. Why do you say t? Because it's what? Because it's minutes. And what's another reason that that would be a t? It's time, because it's labeled right here as time. Okay, how do I get the distance if my time is 0? What do you suppose I would do? So as a team right now, I'm going to give you a minute or two to chat, probably 30 seconds. What am I going to do to get my distance if my time is 0? So take a second to chat. Ready, go. What am I going to do with that 0 for t? What do you think, Sebastian? So I'm going to substitute this 0 in for t and solve to get d. Does that make sense? Your job right now is to fill out the table and then stop. I don't want you to graph something before we've checked it. So Mrs. Eder and I are going to come around with the yellow half sheet. All you're doing right now is filling out the table. All right, ladies and gentlemen, just as a reminder, so we're going to substitute the 0 in for t. So I'm going to have d plus 4 equals 2 times 0. Okay, d plus 4 equals 2 times 0 is 0. To get d by itself, I subtract 4 on both sides. d equals negative 4. And then I'm going to fill in my table right there with the negative 4. Thumbs up if you're with me on that, guys. Okay, I'm going to put the table up so you can double check your answers. So the table should look like that. All right, ladies and gentlemen, take that information and plot it on this graph. So give you a minute as a team to go ahead and plot that table. Ladies and gentlemen, if I look at the ordered pair 5, 6, what direction do I go first? Sydney, what do I do first? So if I go 5, 6, how do I move? You know what, I can't hear you. Up, down, left, right. That way. Right. You go right. 1, 2, 3, 4, 5. And then where do I go? Up 6. Then I have to go up 6. If you're not sure, this is representing your x-axis. These numbers represent your y. This right here is my x-axis. So I have to move 5 on the x and 6 on the y, and this is my y. Okay? All right, so my graph should look like this. So take a second to quick double check your graph to see if your graph matches my graph. And then, ladies and gentlemen, we're going to give you a couple minutes right now to answer the questions at the bottom. So I'd like you to look at the x and y intercepts. Does it make sense in this problem to connect the lines? We all did. So why would we connect the lines? Why does that make sense? The type of function, if you know what that is, that'd be awesome. Independent, dependent variables. Tell me how to calculate the slope 2 different ways. And then if you think you know the domain and range, go ahead and answer that question. You need to look up these vocabulary terms if you have no idea what an independent-dependent variable is, or if you have no idea what the x and the y-intercept is. So you can use your book as a resource. All right, so Mrs. Eder and I are going to give you a couple minutes of work time to answer these questions at the bottom. We're going to need you to work as teams to get your answer. So I need you to collaborate with your team members and look some information up together. And look at what you guys have for your answers here. We're going to run through all of them. Let's start out with the x-intercept. What is an x-intercept? Actually, let me back up. What is a y-intercept? We've been dealing with a y-intercept for almost the entire school year. So what's a y-intercept? Alyssa?
It's where the point crosses the y-axis.
And we've been dealing with that for a long time. The point where the line, here's the line, crosses the y-axis. So here's my y-axis, here's the line. This right here, this point, is my x-intercept. Excuse me, I said that wrong. That's my y-intercept. So for the y-intercept, you should have 0, -4. If you don't have that, might be a good opportunity right now to make sure you have the correct answer. So now can we back up? What is an x-intercept? So the y-intercept is the point where it crosses the y-axis. Sid? So I'm looking at the line, I'm looking at the x-axis, and it looks like this point right here is where it crosses the x-intercept. So my x-intercept is 2, 0. Okay, I'm going to ask you to take 10 seconds to turn and talk to the people at your table. What do these two ordered pairs have in common? It's okay to state the obvious. So ready? Turn and chat. Who can tell me the obvious answer? What do these two ordered pairs have in common? Kyler, what do they have in common?
They both have 0.
Okay, that seems like a really silly, simple answer, but they both have a 0. If there's a 0 for an x value or a y value, that's telling you it's on the x-axis or the y-axis. Can I point this out to you, though? This is the x-intercept, and what value is 0? Is it x or y? So this 0, is that x or y? That's y. So an x-intercept has a 0 for an x-coordinate. A y-intercept has a 0 for an x-coordinate. Okay, so when you're looking at a table, that's one way you can differentiate between an x and a y-intercept. If you're not sure, I would take a second to sketch a quick graph and see, does 0, 4, does that line up on the x-axis or the y-axis? All right, that's important to note. 5, 6 is not an intercept because it's this ordered pair right here. It's not on an x-axis or a y-axis. So when you're asked to look at an intercept, you want to zoom in on those zeros. Okay, why do we all take a ruler and draw in a straight edge, a straight line on these points? Kylo, why do we do that? No, well, I see where you're going with that. Do they all fall in a straight line? Do they make a W or an S or a C or a V?
No.
They all fell into a straight line. So, yeah, it makes sense to connect the points because they're a line. The next question, I'm not sure if anybody knows the answer to. Some of you probably got to in Mathia. But describe the type of function. What kind of function is this?
A linear function?
It's a linear function. If you don't have this answer, you might want to take a second to go ahead and jot it down. I want to point out that linear, the first 4 letters, spell line. So in this chapter, we're looking at linear functions, functions that graph to be lines. Independent and dependent variables. When I'm looking at this here, you have to ask yourself, does distance depend on time or does time depend on distance? Because my variables are going to be the 2 things found in the table. All right, so what depends on what? Does time depend on distance or distance depend on time? Sid?
Distance depends on time.
Do you know why distance depends on time?
Kind of just instinct.
So if I'm going to go for a run, how far can I go? It depends on what? It depends on how long I'm running. So if I'm running for 2 hours, I could run a lot further than I did if I run for 10 minutes. So make sure you have this down. Independent is time, dependent is distance, because my distance depends on the time. Just as a quick note, the independent variable is always your x. So you could pull that right out of the table without thinking about what depends on what. Okay? Slope. Calculate slope using 2 methods. The first method is our equation, y sub 2 minus y sub 1. Me personally, I always pick the variables that have the zeros in it because it's pretty simple to add, subtract, multiply, and divide by 0. So 0 here is my x sub 1, 2 is my x sub 2. Negative 4 is my y sub 1, and 0 is my y sub 2. So I'm going to plug that into my equation. Oops, I'm sorry, this should say m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it looks like I'm going to get 0 minus negative 4 over 2 minus 0. Do you guys see this double negative happening here? Some people struggled on the assessment in my D group because of the double negative. How do I fix this? What do I do with that? Bella?
Put parentheses in.
I could. And then what do I do with the negatives? Beavers, what do I do with that? I have to add the opposite. 0 plus 4 is 4 over 2. So my slope, which I still have to simplify, is 2 over 1. That's one way. The second way is using the table. So I pick 2 points. Josh, does it matter what 2 points I pick? It really doesn't. So if I pick these first 2, I have to do rise over run. I'm going to get 1, 2, 3, 4 over, 1, 2. 4 over 2, which simplifies to be 2 over 1. If I pick the outside 2, I'll get 6 over 3, which simplifies to be 2 over 1 as well. Okay? This half sheet is a study guide for your test. So you're going to want to make sure you keep that. All right, ladies and gentlemen, in your notebooks, I want you to jot down these notes. Let's go over the form of a standard, or the standard form of a linear equation. You guys are used to seeing an equation written like this. Slope-intercept form. This is different. So this form is slope-intercept. This is standard form. The difference between these two, A and B, X and Y, I should say, X and Y are on the same side of the equal sign. Do you guys see over here, Y and X are separate? Y is on the left, X is on the right. So that's an important distinction to make. A, B, and C are constants. So constant is a fancy way to say number. So can you go ahead and add that to your notes? But what's important to know is A, B, and C can't all be 0. 0 is a number, but A and B, only one or the other can be 0, but not both of them. And then here are some examples of equations in standard form. I want to point out again that X and Y are on the same side of the equal sign. So when you're putting something in standard form, AX, or the X term, has to be the first thing I see, followed by a plus or minus sign. Then I'm going to see the Y term. Then I'll see the equal sign, and then I'll see the number that's all by itself without a variable last. Okay? All right, we're going to take some equations and convert them into slope-intercept form. Some of your sheets have these equations on the back, and some of them don't. So some of you are going to have to look up at the board. So can everybody look at number 1, whether it's on the back of their sheet?
Put it in your notebook then.
Yes.
If you don't have it on the back of your yellow sheet, put it right underneath your notes.
Excellent point. So right now, equation number 1 is y equals 3x minus 7. So if you don't have it on your sheet of paper, Ryan, you're writing it down, please. This is in slope-intercept form. How do I put this in standard form? And remember, a big difference is X and Y need to be on the same side of the equal sign. So, suggestions. What do you think I need to do? What's your guess?
3x minus y equals -7.
Close. So I have to do something with 3x. How do I put this term over here? Josh? I'm going to have to subtract it. So now I'm going to have negative 3x plus y equals -7. ax plus by equals c. So this equation is in standard form. All right, ladies and gentlemen, we have two